Hi dear students, welcome to Geeta's classes. In this class, we are going to do some problems on Laplace transform, that is find the Laplace transforms using the function L of t power n into f of t. In the previous class, we have seen the theorem how to find out the Laplace transform of t power n into f of t. Now, by assigning some function f of t, we will do some problems. Before that, these are the basics of Laplace transforms. You have to be thorough with these formulas. L of f of t, L of k, L of 1, L of e power at, L of e power minus at, L of cos at, L of sin at, Laplace transform of cos h at, sin h at, Laplace transform of t power n. These are the formulas. All these proofs are available in the previous classes. If you want to learn, please go through them. And first shifting theorem also we have seen. So you have to remember, if you want to use L of e power at into some function, so without this e power at, you find the Laplace transform and in which s should be replaced by s minus a. If it is e power minus at, then s should be replaced by s plus a. Now L of, if the function is multiplied by t power n, then if it is multiplied, differentiation, remember differentiation, multiplied means differentiation. So minus 1 power n into, how many times you have to differentiate? If it is t power n, d power n, ds power n of f bar of s. What is f bar of s? L of f of t. Always remember, L of f of t is equal to, remember this step, L of f of t is equal to f bar of s. F bar of s means immediately you should be able to relate that. It is nothing but L of f of t, Laplace transform of f of t. Okay. So after finding that, it will be a function of s. So that is why we are differentiating n times with respect to s and multiply by minus 1 per n. So now let us do the problems. Find L of t into e power minus at. That is L of without t, that is e power minus t, you have to find out. Then differentiate this with respect to s, attach 1 minus. Why it is minus? Here it is t power 1. So minus 1 power 1, that is minus d by ds of L of e power minus t. So minus d by ds of e power minus t is what? L of e power minus t is what? 1 by s plus 1. Right? So this 1 by s plus 1 I have to differentiate with respect to s. So minus 1 by s plus 1 the whole square. That is 1 by s plus 1 the whole square. The same problem you can use with by applying first shifting theorem also. That is L of t into, this is another method. Either you can use this t power n or e power minus at also. E power minus t is equal to, whichever you feel easier you can do that. So L of t, without e power minus t, L of t you have to find out, in which s should be replaced by s plus 1. What is L of t? We know the formula, n factorial by s power n plus 1. So 1 factorial by t power s power 2, 1 plus 1, 2. So 1 by s squared, in which s should be replaced by s plus 1. That is 1 by s plus 1 the whole square. The same for answer you will be getting in both the methods. Okay. So next is L of t into cos t. L of t into, if the function is multiplied by t, then without that you find out, that is L of cos at, then differentiate with respect to s, d by ds of, and minus 1 per. So minus d by ds of L of cos at. That is minus d by ds of, what is L of cos at? Laplace transform of cos at formula, s by s squared plus a squared. Now you have numerator also s, denominator also s. So u by v form you have to use. That is minus of, let us differentiate this. Always you start with v squared, that is s squared plus a squared the whole squared, into v into du. That is s squared plus a squared into differential of the numerator, that is 1. If you differentiate s, that is 1. Then minus of s into differential of v, that is 2s. Okay, that is minus of s squared plus a squared minus 2s squared divided by s squared plus a squared the whole square. That is equal to minus of a squared minus a squared. A squared minus 2a squared, so minus a squared divided by s squared plus a squared the whole square. That is s squared minus a squared divided by s squared plus a squared the whole square. Okay. Similarly, you can find out L of t into sin at. The answer will be 2as by s squared plus a squared the whole square. Please try. Okay. The same way. Without t, you have to find out the Laplace transform of sin at, then differentiate with respect to s and attach one minus. Okay. So if it is t squared, then twice you have to differentiate. That is minus 1 per 2 minus 1 the whole square d squared by ds squared. That is by the theorem into L of sin at. Right. That is minus 1 the whole square is 1. So d squared by ds squared of, what is L of sin at? A by s squared plus a squared. That is, once let us differentiate d by ds of minus 1 by s squared the whole square. So minus a by s squared plus a squared the whole square into, you have s squared here, so you have to multiply again, so 2s. That is d by ds of minus 2as by s squared plus a squared the whole square. Right? That is d by ds of, or minus 2a, I will take it outside, into d by ds of s by s squared plus a squared the whole square. That is again u by v form let us do. That is minus 2a into, denominator is s squared plus a squared the whole squared we have, so it will become s squared plus a squared the whole power 4. So here s squared plus a squared, v into the whole squared. Okay, s squared plus a squared the whole squared is there in the denominator, so that is our v. So s squared plus a squared the whole squared into, numerator is s, so 1 minus of s into, differentiate this. Here you have s squared plus a squared, denominator you have s squared plus a squared the whole squared. So 2 into s squared plus a squared into 2s again. Okay, s squared if you differentiate 2s. Got it? So this is equal to minus 2a by s squared plus a squared the whole power 4 into, numerator, in the first term I have s squared plus a squared the whole squared. Next term I have one more s squared plus a squared. So I can take that s squared plus a squared outside. Into, here s squared plus a squared, 1 s squared plus a squared is there. Minus, here 2 into 2, 4 s squared into, so 4 s squared. Right? So 1 s squared plus a squared, and this 4 will become 3. That is minus 2a by s squared plus a squared the whole cube into a squared minus 4 a squared. Sorry, minus 3 s squared. Here s squared minus 4 s squared, so 3 s squared. Or you can say 2a into 3s squared minus a squared divided by s squared plus a squared the whole cube. This is the required answer. Okay. One more problem, let us see. L of t into e power minus t into sin 3t. So let us recollect, if the function is multiplied by e power at or e power minus at, first shifting theorem. That is, without e power at, you have to find out the Laplace transform and replace s by s minus 1. If it is multiplied by t, then d by ds of differentiation. Okay. So this is equal to, I am going to write it as minus d by, now for t into e power minus t. So minus d by ds of L of e power minus t into sine 3t. That is equal to minus d by ds of L of e power minus t means L of sine 3t you have to find out first. Then in which s should be replaced by s plus 1, right? That is minus d by ds of sine 3t. If you differentiate, it will be, sorry, L of sine 3t is 3 by s squared plus 9, right? S squared plus 3 squared, in which s should be replaced by s plus 1, or minus d by ds of, or you can differentiate and then replace s by s plus 1 also is fine, no problem. So minus d by ds of 3 by s plus 1 the whole squared plus 9. That is minus d by ds of 3 by s squared plus 2s plus 1 plus 9. So 10. Right? That is minus d by ds of 3 by s squared plus 2s plus 10. That is, when you differentiate, minus of minus 3 divided by s squared plus 2s plus 10, you are differentiating this. So into 2s plus 2. Okay. So minus minus it will become plus. So 6 into 2, I am taking it outside. So 2 into s plus 1 I can write. So 3 into 2 it will become 6. So 3 into 2, 6. So 6 into s plus 1 divided by the whole square. Sorry. Minus 1 by s squared. No. So s squared plus 2s plus 10 the whole square. Okay. Or else you can find out you can differentiate first, then replace s by s plus 1 is also fine, whichever you feel easier. And you take this as a practice problem, and the answer I'll give you, you can verify the answer. Please take it as a homework and do it. Practice problem. Minus 6s plus 5 divided by s minus 3 the whole power 4 plus 8 into s minus 3 the whole square plus 16 is our answer. Please practice this problem. And if you feel that it is useful for you, please give a like and please share it with your friends also, so that it will be useful for them. And thank you so much for listening.